Soon after dark on April 23, 2019, a rural village in the Costa Rican rainforest found itself on the receiving end of one of the most important meteorite strikes in half a century. In a blazing display, a space rock the size of a washing machine broke up in the atmosphere and plummeted to Earth. Aguas Zarcas would become synonymous with the meteorite fragments that crashed in cow pastures, burned through roofs, and set the science and collecting world on fire. The rocks are carbonaceous chondrites, one of the rarest types of meteorites, rich in carbon. Some of the carbon takes the form of complex organic molecules, such as amino acids, the ingredients for proteins. They show how complex chemical reactions in space may have seeded a barren Earth 4.5 billion years ago, with building blocks for life. Aguas Zarcas is a kindred spirit of another famous meteorite, known as Murchison, which crashed into an Australian cattle town in 1969. Murchison contains a menagerie of organic compounds, for example, the sugar ribose, part of the backbone of RNA, that have seeded the field of astrobiology for half a century. Though Murchison beat Aguas Zarcas to the punch, the freshness of the Costa Rican meteorite gives it an advantage. Thanks to modern techniques, scientists can better preserve its fragments and take a more intricate look into their past. Inside Aguas Zarcas, they hope to discover remnants from 3 different ancient periods. First, a time 7 or 8 billion years ago, long before the solar system was born, when stars and supernovae shed fine grains of materials, like graphite and silicon, essentially stardust. Second, a time 4.5 billion years ago, when a hot, swirling disk of gas and dust led to the birth of our sun, and bits of radioactive aluminum and calcium condensed out of this seething disk. Third, a period millions of years later, when these primordial particles began to clump together into protoplanets, while others, such as those that form Aguas Zarcas, lay low in the cold void beyond Jupiter. There, the particles gathered ice and carbon, which in the presence of heat and light reacted to form the complex organic compounds. Following several more billion years of isolation, a wayward collision in space splintered off a chunk of this asteroid and sent it on a collision course with, of all places, Aguas Zarcas, Costa Rica. Meteorite dealers, knowing the rock's immense value to science, immediately descended on the region. One early arrival secured fragments for a few dollars per gram. Then other collectors arrived, driving the price upward of $400 per gram, more expensive than gold. Villagers were able to purchase cars, pay off loans, and even open restaurants with the bounties they received for the meteorites they found. Eventually, some of the fragments ended up at Arizona State University, after a handoff from one collector who hoped officially classifying the rocks would help increase their value. Others found their way to the Field Museum in Chicago, where they were preserved in liquid nitrogen. However, because of the collector frenzy, Costa Rica has been left with only a tiny fraction of what first landed on its own soil. Analysis of the Aguas Zarcas fragments may help shape science's understanding of the early solar system, and it serves as a trial run for space missions that will soon retrieve samples of asteroids that resemble Aguas Zarcas. Japan's Hayabusa 2 spacecraft has collected samples from the asteroid Ryugu and is scheduled to parachute to Earth in December this year. And in 2023, NASA's OSIRIS-REx aims to deliver another 60 grams of material from the asteroid Bennu. Both asteroids are carbon-rich, and their samples hold promise as time capsules from the solar system's birth. The scientific fiesta that kicked off in Aguas Zarcas last year shows that a meteorite's impact doesn't end when it hits the ground.